caught a glimpse.
Do not show me.
Maria is the one person that's going to survive this class.
Oh my God.
We're all gonna die.
I actually got goosebumps.
We're all gonna get trapped inside with Mark.
A description again, but just nobody ever believes
I thought you
what I
said
say.
sunflowers, not sunflowers.
If you show me that picture, I will take it as a threat.
You missed
and I will
something
throw
and you're
that
welcome.
phone across the parking lot.
My God.
Or now, every time, like, something goes bump in the night in our house.
No, you have to show the video. So that I
No,
can
no, no,
show
no. I didn't. I wasn't recording. I'm so
No.
sorry if you want. What?
Put it back on the video.
No.
So that when I get home, I can show
That
you.
was so much creepier than expected.
Nobody ever believes
I
it.
didn't. Yeah, and it says Mark on the inside.
It does. It's just
Okay.
a gift to you?
That's
Yes,
hilarious.
from my
A
grandfather.
gift?
Well, yeah. But now every time something goes bump in the
And
night.
then to see what he
we
gave
just
you
say,
didn't-
"Oh,
if you
it's
didn't
Mark."
At least you know what it is.
Like, he's so powerful. His negative energy is so powerful that it keeps all
His
the other
aura.
malicious spirits
That's
out.
hilarious. That's like Yoda.
Maria, you know those mirrors you put on top of doors?
The what?
The mirrors you put on top of doors? No.
I put coconut leaves on my doors.
Coconut leaves?
Yeah, you burn them and then you put them on the doors.
Like to ward off things like Mark.
Oh,
I knew that.
Keep Mark out of my house.
Mark is my
Melissa
listen.
won't.
there's a pile of masks outside of Maria's door that just had to stop.
Don't show her.
Well, what happens when Mark is your friend though?
That's what I mean. He keeps all the other
He's
guys
on your
secret
side
in our house.
technically.
How long have you
If you invite him in, if you're cool with him there, that means he'll like defend your home from other evil spirits.
It's like spiders versus like roaches.
Yeah.
These are all really good theories. We're gonna have to. How long? So you've had Mark for 8 years.
Yes.
Okay.
She's still okay.
You made it this far.
Because I haven't gotten rid of him. And I never can, and I never will.
So
You
is
have-
he gonna be like in your basket? Like,
No, like I gotta pass him on when I die.
Please tell me you've never actually put Mark on.
Oh, for sure. I used to scare my sister.
Oh,
all the
really?
time.
Oh, okay, okay. All right.
I would like stand over her.
Aubrey's like
Before she woke up.
quadruply cursed. All
it's a
right.
little late to Halloween,
Man.
guys.
How do I bring this back? Okay.
It's the
How
same.
do I? How do I segue? How do I
Then you
transition?
just go home actually.
hold our loved ones?
Yeah.
Calvin is
Go
also
ahead.
gonna live.
So,
Come go home, dude. Go home. We're all cursed.
I'm scared.
What?
no,
We've all been cursed.
So how many times
you're just be happy you weren't here earlier. You would have seen something that would have sucked your soul out.
Yeah. The devil.
I still have goosebumps.
That is the most different way to start a class I've ever had. Okay. Anybody else have cursed items? We can really change my YouTube channel from math teaching into exploring cursed items. That would be different.
I've watched like 12 videos back to back. Videos
Oh,
in order.
I thought you were
That's
just saying,
like the last
I watched like
16
12
days.
videos of people cooking potatoes.
No. I just go in order. I play
Oh, okay.
speed.
All right.
What's it called when they like live for ghosts?
Ghostbusters?
No, ghost hunters. Yeah.
Those, yeah,
Where they wear the cameras facing them.
when they have like the little sensors.
Yeah.
That's us.
Oh yeah.
All right. Let's review now. I'm not even gonna try to segue. Let's remember what we learned last time, which is a long time ago. By the way, I hope everybody's week went as well as possible. I know already some of us didn't have the best week ever. I unapologetically had a fantastic week, so. Go you, Joe. Here's the thing. So, do you guys realize that next week is the final? Number one.
Next week?
Next week. A week from this Wednesday.
That's insane.
I know. I agree.
Why can't we do it on Tuesday and then just we also show up and hang out on Wednesday? No. Okay.
I mean, we could.
Hang out.
Yeah.
Maria's like, I wanna hang out with you guys.
Um,
Why could I be here? Absolutely.
so, let's see. So okay. So everybody's now fully aware. Thanksgiving happened, we came back, we're all freaking trying to transition back. And then, like me and Maria were talking, next week is finals. Next week, Monday and Tuesday are review. So I'm gonna give a, oh God,
Oh, he looked at it.
sorry, Nas. You're-
He gets closer.
You're gonna get sucked into the.
7 days from now, you're gonna get a phone
Here's the
message.
story.
Please, because it's what finally makes me.
And they're gonna say it's Mark.
So, it'll be perfect timing.
Oh, good, alright. So, this week, we just have like, one section and 2/3, basically. Last time, we got up to a little bit of 9-3. We got like 1/3 to 9-3 done. And I'm gonna review with you what we did last time. Seems like a good idea. It'll be a nice palate cleanser. And then I've got, you're not gonna believe it, I've got like a handout so you guys can practice some of this stuff. I'm gonna give a practice final, I'm not sure exactly when, I'm gonna try to put it together potentially by Wednesday at the latest, so that Maria's Thursday office hours could include the practice final as like something for you guys to talk about. Just remind you guys again, next week, Monday, Tuesday, are in-class reviews for the final. We can talk about anything for the whole semester. Okay. So just to review, I'm not gonna redo, I'm gonna remind you guys what we did last time. We figured out what this is. I've got like Mark in my head. I can't get rid of it. Okay. Does anyone remember how to, it was a suggestion of my part, but you can have a different way to remember this. My mark? It's a suggestion of my mark. God damn it.
You're gonna start saying Mark on that.
Does anyone remember
Yes.
either one of these? It's,
Sine A, cosine B.
yeah, so sine's a nice guy.
Yeah.
Right, sine's the guy is like everybody take turns.
Sine shares the toys.
Yeah, sine's like, come on over here, cosine. I'll take A, you take B, I'll keep this a plus sign, and then I'll do B and you do it. Right, and again, I know that the derivation was a little long, it's a little freaky. I personally loved that thing we did last time. I know there might be some people that feel differently, but just to remind you guys, if you weren't here, you really should watch that video. Just so you have it, we basically worked with this, and we broke down all the sides, and we actually developed, for example, this, from looking at the sides of the triangles in this shape. Okay. So at the very least, even if some of the steps I did didn't make sense, you know it's grounded in something. It came from a very physical place, not just out of nowhere. What was the difference with cosine? What's the major difference with cosine?
He doesn't like to share the toys.
Yeah, cosine is
You first.
an asshole. Cosine says, all right, I'm gonna take him. So like Damien said, he's gonna play with me first. He's gonna change that sign, screw you. And he's like, all right, son, go ahead, I'm done playing. You take it. Okay. Now obviously, everything I just said is slightly not mathematical, but it's just a way to kind of remember this stuff. When you go into calculus, they're gonna expect you to know this. They're gonna expect you to know basically every trig identity we've talked about so far. All right. And then what's the only difference if I do like minus? Let's say the sine of A minus B.
It's the same thing, but you have a minus. with
Yeah,
the
so sine again, nice guy, keeps the sign. And of course, if I just make this a minus, if I can do this quicker, this becomes a plus. Is that cool? Just have to write less. Okay.
Yes.
Okay. This is where, as a student, you start to lose the thread that all trig functions are basically ratios of sides of right triangles. That was the first thing we did. Still is. It just happens that these relationships hold. This led to figuring out what this was. Does anyone remember how I can use what we've done here to figure out what this is? What's 2 theta mean? What's 2 anything? 2x, 2 theta? 2 times theta. Now use addition. What's 2 theta?
Theta plus theta.
Theta plus theta. So if I have sine A plus B, I know what to do. Doesn't matter what A and B are. No, that's the whole point. That's why I put A and B. It could be any number I want. So what's sine of theta plus theta? What would sine of theta plus theta be?
Sine 2 theta.
Well, no. Well, yeah, you're right. Sine 2 theta. But now what's sine theta plus theta using this?
Sine theta, cosine theta, plus sine theta, cosine theta.
Yeah, so sine 2 theta is 2 sine theta cosine theta.
Actually,
Now let's check this out real quick. Let's make sure this actually makes sense. Let's do something very concrete, right? Let's check out what sine of 60 degrees is. We already know what sine of 60. Can somebody tell me what sine of 60 degrees is?
Half.
Do it again.
Half.
No. What sine is 60
3 over
degrees?
2.
Root 3 over 2. Yes?
It's either
So watch this. So a little side note here. Sine of 60 degrees. You all agree with me that's sine of twice 30 degrees? That's amazing, Jeff. The things you can do. All right, now, I want you to understand. I'm going to use this in a really stupid way. We already know what sine 60 degrees is. I want you guys to buy into this a little more. I want you to see this concretely work. Sine of 60 is sine of twice 30. I can now use this double angle formula. Right? What am I going to replace the thetas with? 30. Because sine twice theta is this. So sine twice 30 degrees is this. What's sine of 30 degrees? Now come at me, whoever said that thing earlier. Yeah, sine of 30 is 1/2. And what's cosine of 30 degrees? Of course, here these cancel. So you do get what you're supposed to get, right? You guys got it with me?
that's awesome.
What happened? Why not? What happened?
Math asked.
Oh, okay.
So you can take the 2 out of the parentheses and put it in front of sine.
So here's the thing. We figured out that sine of twice an angle is twice sine of the angle, cosine of the angle. That's what that says. We know that's true. We built it off of sine of a plus b. And sine of a plus b we got from that crazy big ass triangle thing. Yes? You guys all with?
So, sine of 2 theta is equal to 2 times sine theta times cosine theta.
Yes.
So is that just like the distributed version of the 2 sine?
Yeah, okay. Let's do this. Is everybody at least accepting of this?
Yes.
Okay. We were here last time. If you weren't here last time, you got the video to watch. On that big ass Frankenstein triangle thing that I gave you, we figured this out. Okay. Not obvious, nothing that I would expect anybody to just kind of do on their own. But I really hope you could follow each step. Even if I lost you at some point, you know it's anchored in reality. You know it's anchored in right triangle stuff. That is true. That is simply true. It doesn't matter what the angles are. That is true. So I just wanted to do a quick concrete thing. So 2 things. We took this and we figured this out. If A and B are the same, if they are both theta, then this just boils down to that. Yes? Yes?
I understand how the left side of the equation happened, but I don't get how the right side of the equation happened.
So real quick. If A and B are both theta, yes?
Right.
Then what does this become?
What do you mean, what
Sine theta plus.
Yeah. This says if I have sine of A plus B, it's sine of the first dude, cosine of the second dude, plus sine of the second dude, cosine of the first dude, right? Okay. So that, it doesn't matter what A and B are. A and B could be whatever. Is everybody with me? Now, again, real quick. Right now, you don't have to be with me with like, even if you were here last time, I understand it was a lot. But just this is what that is equal to. I can feel some people talking about this in a certain way. I didn't distribute sine. That's not what this is. That is so not what this is. Because this does not say sine times this. Is everybody cool with that? How do I read this?
Sine
Of. So A plus B is inside sine. This just happens to be a way to rewrite this. This is equivalent to this, no matter what A and B are. Yes?
So then like 2 theta just be 1b.
Yeah. So if I made A and B both equal to theta, and what's theta? It could be 30, it could be 47, it could be 211.793 degrees, right? It could be whatever angle. I'm just saying they're both the same. Is that cool? Then I'm like, what would happen? So I've got a relationship for the sine of the sum of any two angles. Yes, that's what that is. The sine of the sum of A and B. I have a relationship. So I'm like, what the shit? Well, what if they're both the same thing? What would happen? Right? Just curious. So if they're both the same thing, how do I rewrite this? If A is theta, what do I put in place of A? Theta. That's crazy. What do I put in place of B? Theta. And what's one thing plus another? The same thing. Two of those things.
Okay.
Now, real quick. Yes, sir.
So why on the back half on the back half of the equation is it sine B plus cosine A? and-
Sine B cosine A.
And not sine A cosine B? Why is-
Up here?
Yeah.
Because that's not what it is.
Okay.
I mean, sorry. That was one time in math I could just say that. Because we all, again, even if last time you lost the thread, because there's a lot going on. So, but if you were here last time, we actually ended up at this place. We saw when I looked at the sides and I looked at the parts that added up to be the whole side, I got this relationship. It's only if I make both the angles the same that I can then put these together. Okay. And we just did a concrete example. When I put 60 degrees in, this actually worked. Does that prove this works that way? No. We proved it works because of this, but it's a concrete example showing it actually working. Good, okay, sorry.
Sorry, I was gonna ask, I've noticed that people don't usually put parentheses around, like would it be wrong for me to go to parentheses, sine theta, cosine theta, parentheses, just to like keep it clearer for my own head?
Oh no, there's nothing wrong with that.
Okay.
Yeah. You could have asshole math people there like, you don't need those, but you can put parentheses wherever the hell you want, you just don't change the problem. So yeah, if you put parentheses here, that's still times, it still means the same thing. But the problem is when people do stuff like this, that's different,
Right.
right? If it was this, you just change the problem, right? Okay, that's the one time that throwing parentheses in is a problem.
Sure.
Okay.
You did LMX.
Yeah. Okay. Let me stop for a minute. If you guys are at a point where you can accept this to be true, and I showed you where it came from. I never want to just tell you, this is what it is, accept it. I went through it with you, and we were all so excited to do it. Then you have to be cool with this next step. Yes? Because we're just saying, okay, we know this shit's true. We know this shit's true, and then this is just me playing with it. What if they're both the same? What the hell happens then? That's a curious thing. So when we do it, we get this much better looking dude. Now here's something, real quick. Here's the most immediate mistake students make in calculus when they're trying to apply this idea. What would this be? It's okay if you make a mistake.
Sine 4 theta?
That's sine 4 theta. What is it if I rewrite it?
2 theta plus 2 theta.
Do it again.
2 theta. Sorry.
2 theta plus 2 theta.
Beautiful. What mistake do you think people make? They just put a 4 here. That doesn't make any sense. Yes? This is the double angle formula. So you did beautiful. Whenever I'm trying to use a double angle formula, I gotta think, what am I doubling to get what's in there currently? Do you see what I mean? People look at this formula and they say 2 and 2, okay, there you go, I got it. No, you don't got it. This is doubling something. What was double? So I'm doubling 2 theta. So the right way to rewrite this is 2 sine of 2 theta cosine of 2 theta. Now that would suck, because do you see how you can rewrite this piece? And then you can rewrite this piece. Okay. We haven't talked about this yet. I haven't reviewed this yet, but there's a double angle formula for cosine. Okay. All right.
Is it a double formula or is it
Do it again. It's an identity. So, formula and identity kind of get intermixed sometimes, but identity is officially just a statement that's true. It's not something we have to solve. It's sort of like me saying 2 times x plus 1 is 2x plus 2. That you can call an identity, because it's like the distributive property. You're not solving for it, it's just a statement of truth. So this is, somebody could look at this and think it's an equation, but I don't have to solve this because it's true for all angles. It's an identity. It's just true. It is itself. Identity. Yeah. I like it. Okay, let me stop for a minute. Yes?
Should we write the quadruple one down?
Do it again.
Should we write the quadruple one down?
Not necessarily. I just wanted to point out an easy mistake people make.
Okay.
Okay. Now, let's look at cosine. So this guy is just a little side note, don't worry about it. Okay. If I look at cosine, can you guys take a minute and do the same thing we just did? I want to know what cosine of 2 theta is. So we're going to do it the exact same way we did earlier, right? Exactly the same way we did earlier. I just have to use this identity here. So you can think of it as cosine of theta plus theta. So again, you're just going to replace both A and B with theta, right?
I think I got it.
Yeah, what's cosine theta times cosine theta?
Cosine squared theta.
That's crazy. What's sine theta times sine theta?
Sine squared theta.
Is there a difference between writing cosine squared theta and cosine?
Okay, beautiful. This just came up earlier today. This is huge in calculus. This is huge everywhere. The minute we start doing this kind of shit. This is math people being lazy, which leads to a lot of student confusion. Cosine squared theta literally means cosine theta and then you square.
So if I write it the second way, I might
Yes.
get yelled at, right?
You might get some math people look at you like,
That's
right?
good.
And then you like, look at me however you want to, as long as my grade don't change, right? This is a much better way to write it when you're doing calculus to it, and you'll see what I mean when you get there. This is really easy to make mistakes because you forget what's being squared. This is just a shorthand. I mean, math people literally, we're so lazy, we're like, I don't want to write those parentheses all the time. Let's just put the 2 there. Sounds good. Are you guys at all with me?
Yes.
A little bit? That to me tripped me up the first time I saw it, because what's cosine squared theta plus sine squared theta? We know this. Yeah, it's 1. It's the most fundamental identity, right? Okay. So cosine squared theta minus sine squared theta is so not 1. Not all the time.
Unfortunately.
Yeah, it's too bad. Now there are 2 other ways to write this. Bless you. There are 2 other ways to write this. So a little side note to help you out. We just said sine squared theta plus cosine squared theta is what? So what is 1 minus sine squared theta? That's insane. What's 1 minus cosine squared theta? Holy shit. Now, can you rewrite this 2 different ways? I want one way to have nothing but cosine in it, and one way to have nothing but sine in it. If you have no freaking idea, call me over or just wait. If you are somebody without any paper out at all, you're freaking me out. You're doing everything in your head, that's really,
Do not do this all.
I am jealous.
It's already on done.
So just to make sure you guys are with me. Wherever in the universe you see cosine squared theta, what could you replace it with?
Oh, we should replace it with.
Yeah, because cosine squared theta is 1 minus sine squared theta. Is it always a good idea to replace it? No. In this case, I want you to, so yes. So for example, if you just rewrite cosine squared theta in this expression, just rewrite this guy as 1 minus sine squared, don't you have some like terms you could put together? So another way to write cosine 2 theta is 1 minus sine squared minus sine squared. So what's that? That's 1 minus 2 sine squared. Do you see how cosine is still an asshole? Look at sine. Sine 2 theta is 2 sine theta cosine theta. Done. Done. It's got one wave. Cosine 2 theta? Oh. It could be this, it could be that, or it could be one more thing. So how do I get the third option for cosine of 2 theta?
Change the sign.
Yeah. What can I replace sine squared theta with? I can replace it with 1 minus cosine squared theta? Yes?
Yes.
Alright, try to do that. I want you to replace sine squared theta with 1 minus cosine squared theta. And you gotta be really careful about the minus sign in the formula in cosine 2 theta. No, someone wrong. Yeah, you made an easy mistake. Close. Minus 1. No. So here's the trick, guys. When you replace part of something with a whole other function like this, you have to put it in parentheses. Then what do I do with that minus? Distribute it. Yeah, so then it becomes 2 of these things minus 1.
I tried to do the distributing.
That'll do it. Alright, listen. I desperately want you to understand. This is so important, so I'm trying to, alright, there's no way to make this overly exciting. We're just playing with it, but to me it's really freaky that there's so many ways that all end up in the same place. I kinda like that. And then, right now you have no idea why it is good to have so many different ways to rewrite cosine 2 theta. Depending on how far we make it tonight, we might see one situation that it's useful to have so many ways to rewrite it. So let me do this right now. I'm going to give you a very green piece of paper. That's the whole classroom. Everybody dropped. Whole classroom fell down. Mark strikes already. You missed out on the lower.
Yo, 607. out of Mark.
Yeah.
Yeah, you guys aren't gonna like get cursed.
Oh, thank God.
Yeah, Aubrey, can you show them Mark?
Oh, no, it's okay.
Can you show them?
Where are you?
I think I know one.
Yeah, you guys wanna look. Make sure you look into it. Make sure you look into it.
Oh, dang.
Oh my gosh, saw it again.
Damon's gonna get 2 phone calls.
Look at Mark.
Look at Mark. It's Mark.
So guys, the only 2 things on here we haven't talked about yet. I figured I'll go ahead and give this to you. We've talked about every bit of this except for this. Half angle formulas. Now, the funny thing about these is they're the most important ones to know for calculus. These 2. Now, let me rephrase that. These are all very important. These show up more often than you might think. You have to memorize everything above this black line by the day of the final. Yeah. By next Wednesday, a week from this Wednesday. Now listen. As we've done these, I've told you you have to know these, yes?
Yes.
So this is not surprising. The only brand new stuff, and we went over this last time. The only brand new stuff is the stuff we haven't talked about yet. So hopefully over time you guys have been committing this to memory as we go. Because to try to commit this all to memory right now, it's gonna suck. Yes?
Can I bring this to the test?
You can bring it with you, but you can't take it out. I love you, Kelvin. You gotta know it.
I mean, it don't hurt to ask.
No, it don't.
That's true.
Right, that's a beautiful lesson, man. I could have said yeah. I could have had a moment of trying out niceness, but no. Yes?
Are you gonna give us the law of cosine again or
No.
not?
Well, it is above the black line.
It is.
Where
That
it
is
says
true,
you
but-
must
So you
memorize
must
everything
you
above.
must memorize it now.
Oh,
Yes.
alright.
Alright.
Memorize it all.
Okay. I was nice to you before, no more.
Yeah.
These just show up, and I've got a lot of people in my calculus class that actually, quite a few of them say they've never taken trig. And that is rough. So you guys are gonna start ahead of the curve for a decent number of students with 180. And just to remind you guys, 171 was not in your placement results. For some reason, they didn't put that in, which is why this is such a small class. Nobody had this as an option. I love that you guys took this course, because you're gonna be so much better in 180, which I'm kind of like, for so many reasons, I hate that I'm not gonna be your 180 teacher, but one of them is, I know you're gonna kick ass. 180 students forgot how to factor. Now, it's been a while since we've done factoring, but I feel like y'all were decently comfortable with it, which is more than I can say for a lot of people. Now, of course, some of them have taken it, and it's been a long time. You guys are going to be so ready when you come into 180, right? Whoever you go with, whoever your teacher is, and please, dear God, me and Maria were talking about this earlier. It doesn't hit me until the day of the final, but I think this class is going to hit me even more, right? When I give you the final, I'm like, I might not see any of you guys ever again, so hopefully you have a good life. As I'm thinking about it, just come by and let me know how things are going, right? My door's always open. If I don't have one of my current students in there, any of my former students can come by and ask for help or whatever if your teacher's busy. All right. So yes, you can see the stuff below the black line get exceptionally trippy. Now, this is based on departmental discussions, but it perfectly lines up with the stuff I have memorized and the stuff I don't. Which is good, because I don't ever make my students memorize more than I have, which only makes sense. I don't want to memorize this shit. So I'm so happy this is below the black line.
So you gonna give us this?
This, if I need you to use any of these, you will have it. I will give it to you. If you need to use any of these, good luck. You should know it. Okay. All right.
Can I bring Mark in on the final night?
Just keep them to yourself. Don't put them up on the wall.
Yeah,
or
bring
anything.
Mark.
He's good luck.
Just put it on the desk next to you.
He's just misunderstood.
I'm just gonna see it, look at him. He's gonna be like,
That's what they said about that.
Alright.
And I agree.
I don't know. I think I saw Mark in that room in the back, and the Conjuring people, you know, with Annabelle or whatever. I think it was over the corner. Yeah.
He's just an adventurer.
He's fucking creepy. Okay. So let's do this. Does anyone else need this? Because there's a few things in the back I want to do with you guys, and then I have a worksheet for you guys to work on. Does anyone still need this? Yes?
Wait, do we use it?
So on the other side, there's all these little problems here. So I'm gonna do a few of these with you. I'm gonna have you guys work on a few of these by yourself, and then we'll do some group work. What do you think on that first one, though? I mean, all right, real quick, just to remind you guys, when I say verify the identity, I am telling you it's true. But you haven't verified it yet. You are not allowed to add or subtract, multiply, or divide both sides. When you add or subtract something to both sides of an equation, that is assuming the equation is true. If we're not certain the equation is true, we haven't verified it's true yet, I can't do that shit. So the biggest mistake people make is they start moving stuff sideways. They can't do that. You pick one side, the other side, or both, and you try to make them meet, make them look like each other. Here's an immediate thing. You can start making a list if you like. Someday I'm going to put a little, maybe I'll do it this semester, a little step-by-step, kind of like, what do you look for first? Whenever I have an identity I've got to verify, I look for squared shit. Why do I look for squared shit? No.
Easier to change.
I've got 3 big identities that are all squared shit. Sine squared plus cosine squared, 1 plus tangent squared, right? Are you guys with me?
Yes.
So if I see a squared thing, I'm like, okay, well, maybe I'll. So look at 1a, now that I've given that shit away. Look at 1a.
Also known as teaching.
Oh, teaching is giving away the idea. Oh, yeah, that's true. Hopefully you accept my gift. Giving away, as long as students actually accept it, not everybody does. All right, so everybody. Focus. 1a. What would we do first? Yeah, 1 minus cosine squared is. So this is a problem I'm going to sort of semi-do with you. So we're going to pick this side to work with right now because it's got the most immediate thing I can do to I can see to do something with. 1 minus cosine squared is sine squared. Any more I can do?
Divide one out.
Yeah, I've got 2 sines up top divided by 1 sine leaves me with how many sines? 1 sine. So that's just, I can't do shit more with that side. Yes? Sine x, that's it.
It's just not. So are we wrong?
But does it look, no, does it look like the other side yet?
No.
No, but you all agree there's really not that much I could do with sine? There's nothing to simplify, yes? So look at cosine x tangent x. Is there something I can simplify there?
Yes, change the tangent to sine over cosine.
Yeah, especially because this side is just sine. So if I can make a sine show up on that side, I'm probably going in the right direction.
Yes.
This is really crucial, and this is not the best example for this. But once you get one side to a place, it's giving you hints for the other side. If I rewrite the other side and have a sine in it, I should be going in the right direction. So like Damien said, tangent x is sine x over cosine x. And what happens here? So that's sine x. And to show me, I need you to do this. To show me that you know what the hell you just did. Yes? This tells me you know what the hell you just did. Now what does that mean when I do that? I made both sides the same. Yeah, so that means that that is true. That side does equal that side. How are we doing so far? So the biggest mistake people make with these verifying identities is they do stuff to both sides. You're not allowed to do that because we're trying to prove it's equal. I can't use something based on them being equal. Let me see. Oh boy, this is gonna be, let's see what you guys think. I do see a square. Oh, good.
So, now we got a sign on that side. It would be sine x is equal to sine x times tangent x.
No.
Or sine x tangent.
Cosine x times tangent x. Tangent x is this, yes?
Oh.
So this equals sine,
Okay,
which is equal to that.
okay,
So both sides are equal because they both equal sine x.
okay.
Is that cool?
Yes.
So you can either make one side look like the other side all the way, or you can make them meet in the middle. What do you guys think about 1b?
Well, there's a number of things you can do. I don't know if any of them are useful.
Real quick.
Oh, you can multiply
Use-
by the inverse reciprocal.
Close. You're sort of thinking the right way, I think. You've gone past it though. Real quick. Do you guys notice how there's fractions on one side?
Yeah.
In fact, there's two fractions on one side. And on the other side, there's one term. Yes? Okay. So when you're verifying identities, you can use the signs to help you. What do I have to do? I know that somehow this becomes that. So one of the very first things I could do, I don't want there to be two fractions. There can't be two fractions. They have to become this one thing. So what am I going to force these two to do? No. I have to add them together. I have to put them together. Yes? How do I put two fractions together? What do you need?
Make the denominators.
I need a line denominator. Yeah. You guys, let me stop for a minute. So be really careful. Cross multiplication only works when you have fraction equals fraction. Then you can cross multiply. Here I have fraction minus fraction. Okay, so everybody with me? Now again, I desperately want you to see this. The problem is telling you what to do. It's like one side of me ain't no fractions, man, so put the other side together. That's your first step. You're getting closer to what the other side looks like if you do that. So how the shit do I do that? What's the first fraction missing? I really want you guys, okay, let me remind you. Do either one of these fractions have a secant x on the bottom?
Yes.
All right, this is where you guys are gonna revolt. No, neither one of them has a secant x. Neither one of them. All right, listen. You ready? If I have 1/8, if I have 1/8, does that have a 2 in it on the bottom?
No.
1/8.
What?
Yeah.
Technically.
It has a 2 times? Or 2 to the...
Any paper.
2 to the third.
It's sorted to.
2 to the third.
If I have 1/8, it has a 2 on the bottom, doesn't it? 2 times 4? Yes. Okay, so 1/8 has a 2 on the bottom. Okay. What about, does it have a 4 on the bottom?
Yeah.
Does it have an 8 on the bottom? Yeah. Does it have a 5 on the bottom?
No.
All right. Tell me again that. Tell that to me again. It does not have a what? It doesn't have a 5 on the bottom. Y'all agree? Y'all agree?
No 6.
Do you all? I agree. It does not have a 5 on the bottom. Do you all agree?
Yeah.
Okay, good. I need you with me. Even though 8 is 5 plus 3, yes?
Technically. There it is.
Who gives a shit? So when I say it has a 2 in it, we know I mean factor-wise. We know I mean something that multiplies to become 8, because that's what LCD is all about. Multiplying to become something else, yes? If it's got an addition of 8 doesn't have a 5 in it, that's stupid. Right? That's why you guys probably meant. But that's exactly the way I see this thing. And I understand you don't, because this is not just numbers. There's all kinds of shit. Do you see what I mean now? Neither one of these has a secant x. One of them has a secant x minus 1. One of them has a secant x plus 1. Yes? You with me? So if I had 1/5 plus 1/3, do either one of those have a 4 in it? Even though 5 is 4 plus 1 and 3 is 4 minus 1. Neither one had a 4 in it because I know I mean factor. Okay, so let me try this again. What does the first dude need that the second dude has on the bottom? That whole damn thing. He's got a secant x minus 1. He's got a secant x plus 1. He needs a secant x plus 1. Actually, let me do this with you guys.
It's like doing x plus 1 times.
Let me see if this is helpful at all. That'd be really good if it was, wouldn't it? We haven't talked about this directly, I don't think. How would you do something like, you could do it, Jeff, this. Common denominator. So how do you find the common denominator? Easy. What's the biggest number that goes into 12 and 40? 12 is 4 times 3. 40 is 4 times. I'm gonna do this because I'm teaching that math for elementary teachers, where x still means times. So then this guy needs a what that he has? What has he got that this guy's missing? A 10. And what has he got that this guy needs? What has he got? This guy, 3. Okay, do you guys see what I'm saying? It's exactly what I'm doing right now. Exactly what I'm doing right now. The only difference is they each only got one thing. So of course, whatever the hell this guy has, this guy needs. So I gotta multiply this first guy by secant x plus 1. Top and bottom. Yes? That's legal because I'm multiplying by 1. I'm not changing a damn thing. Yes? And then multiply the second guy by what? Secant x minus 1. So I'm working with the left-hand side, and I'm just going to see how far I can make it. So on the top, I get secant x plus 1. That's amazing. On the bottom, what the shit am I going to get? You guys see how this is a difference of pairs kind of thing? You see what I mean by that? Difference of squares. There it is. The middle terms will cancel, yes? Do you see that? So I don't have to worry about it.
Where's the secant
square.
Do it again.
Where's the division? Well, no, I see that, but like, what do you?
So I took-
When you're foiling it, are you? I'm with you up to this point, but are you foiling when you're foiling it?
First times first, yes.
Is it secant x times secant x?
Hell yeah.
Okay.
Hell yeah. Sort of like if I had the square root of 7 times the square root of 3, can I multiply the square roots together? No. I got to take the square root of 7 times the square root of 3, right? So here, I couldn't see what I was doing. Secant x times secant x is, that's crazy. And then minus secant x plus secant x. The middle terms cancel, yes? And then negative 1 times 1, minus, that's insane. Minus, on the top of this one, I get secant x minus 1. And on the bottom, I get the same thing, yes? That's the whole idea. I was trying to get LCD. Okay, let me stop for a minute. There's a lot that goes into this problem. So you have to understand LCD, you have to understand how to look at LCD in this case. I need to, now do they have the same denominator? Yes. So I can combine the tops now, right? Yes? What's 3/11 plus 2/11? 5/11. So I can combine the tops now, yes? Okay. I'm subtracting them though, yes? So this is exactly the same thing from earlier. This subtraction has got to distribute. Because I'm subtracting both of these, yes? You guys see that? Okay. Are you guys cool with me if I said 4 minus 7 is the same thing as 4 plus negative 7? Is that cool?
Yeah.
So be cool with that. Alright. So let me put a plus and then I'll put a negative in front of the top. So therefore the negative has to distribute. What am I subtracting? I'm subtracting all of this shit. Both pieces. So the biggest mistake I see is people forget to distribute the negative. So I get secant x plus 1 minus secant x plus 1 all over. What happens on the top? No, don't over there, just the top. Just the top right now. You're right, the bottom we're going to talk about in a second. The top, secant x minus secant x is gone, and then 1 plus 1 is 2. It's crazy. I like, Elijah's like, I knew you were going to catch up. So on the top we get 2, and then Damien says something very interesting. What did you say the bottom becomes, man?
Tangent squared?
Yeah, because what is 1 plus tangent squared x? Secant squared. So what's secant squared x minus 1? Tangent squared. How we doing?
Where did you get 2 on the top? Why isn't it
What's
2?
secant x minus secant x? These cancel.
Right.
What's 1 plus 1?
But I thought they were all one term together.
What do you mean? Sorry.
Secant x plus 1.
No.
You can't really-
You just changed the problem. This is secant x.
But earlier when they were on the bottom of the fraction, you couldn't separate them.
What do you mean?
Like,
Oh, no. I need you to be with me on this.
I I want to be with you on this. Okay?
What is subtracting on the bottom of this problem? I'm subtracting two things, right? That's secant x. And what has somebody done to secant x? They're taking one away from it.
Okay.
What you're saying is this.
Oh.
What you're confusing it with is when I said there is no secant in this, there's no secant x, it's because this is a difference, not a product, right? So when I say 1/15 has a 3 and a 5 in it, that makes sense on the bottom. But it don't have a 7 in it, even though 7 plus 8 is 15. Because it's got to be based on multiplication. It's got to be a factor of it. Okay. So be really careful to throw print. That totally changes the problem. Okay.
So that's secant, like parentheses x minus 1, right? Like secant
That
of
would be
x
different.
minus
That is different. That is completely different than what I
not
have.
that one. So secant of x minus 1.
That's, yes, secant of x minus 1, yes.
Okay.
I hate all these extra letters, man.
Oh, well.
So secant minus
Yeah, again, it was just really stupid picks for function names. Square root kicks ass. Square's a little symbol. But then we had to use words for this shit. Oh well, we weren't around. If you make a time machine, let me know. So, let's catch back up. Is everybody cool with secant squared x minus 1 is tangent squared? You guys with me on that?
No.
Okay, help me out. What are the three Pythagorean identities? I'll start. Sine squared x plus cosine squared x equals 1. What's another one?
Tangent squared x plus 1 is equal to plus
Tangent squared x plus 1 equals secant squared x.
Now,
Cotangent squared x plus 1
equals
cosecant squared. It's kind of nice the co's go together.
Yeah.
Then it finally makes a little more sense why we did the co shit the way we did. Let me stop for a minute. Good. So whenever you see squared stuff, you think this could very likely be related to a Pythagorean identity, but it could be one where they move stuff around. So does everybody see on your green sheet? Does everybody see on your green sheet where it says 1 plus tangent squared equals secant squared?
Yeah, but would it be?
So what do I get when I subtract 1? So secant squared x minus 1 is always and forever equal to tangent squared x. So if I ever see secant squared x minus 1, I can replace it with. And tangent is on the bottom, correct?
Yeah.
What's 1 over tangent?
Cotangent.
Cotangent. So what's 1 over tangent squared? Cotangent squared. So did we make it to where we need to be? Check! That's where we needed to be.
Can we go back down?
Yeah. Someday I'll actually give myself enough space on these things.
I think you should write too big.
I got it on.
I'll write what's smaller for myself. I figure you guys probably need to see this. I did have a teacher that would write very small, and he would whisper to the board. So we were all like right here. He would whisper to the board. And then I had another teacher that would write and immediately erase what he was writing. I have no idea. I have no idea.
Psychotic.
I know.
I want you to fail.
So
You're like, you better be paying attention.
I'm not as bad as I could be, yes.
So this is like the final part, you don't have to write anymore, just to.
Yeah, well, how do I know I'm done?
It looks like the other side.
Yeah, I took one side. Now this is a situation where we took one side, we worked with it all the way until we made it look like the other side. Which means this equals that. We just showed it, yes?
But you have to prove that 2 over tangent squared x equals 2 tangent.
No, that's true. What's 1 over tangent? By definition, what's the reciprocal? Cotangent. So what's 1 over tangent squared? Cotangent squared.
Yeah.
So 2 over tangent squared x is 2 cotangent squared x. It just is.
But you
That's,
didn't write it, so
but
that's-
like, you could say like, what's 1 over secant x minus 1? That's tangent squared. You know, like, where do you stop proving?
Oh,
Cause like
the
technically
minute
you could prove it more. Like,
this is directly equal to tangent squared, yes?
mhm.
I couldn't like do 3 steps without showing all 3 steps.
So that's
I couldn't go from here to there. That would be a problem.
So like the next step.
Yeah, the next step is 1 step away. This is this. By an identity we all know. So there's no work to show this becomes this. And then we know the identity 1 over tangent is cotangent. There's no work to show here. Because we know the identity. Yeah? The only thing you have to do at the end is just show me, understand what the hell just happened. That's where we want to be. So we've taken one side and we made it look like the other side, which means this identity is true. No matter what angle I plug in, this is equal to that. Now, real quick. On one level, this feels like we're just playing with math and what to do. But you have no idea. I mean, trig shows up everywhere. And if you can simplify something, and that's what this is trying to do, it says, oh good, you know some identities? Great. Or you got a little sheet next to you with some identities? That's great. Can you freaking use them? Can you see where they show up? Because that's the part you're going to have to do in real life. You're going to have these situations and all these things, and you're like, can I kind of get this condensed so I can make my computer program run faster so it's not doing all some weird shit? So this is really, and you have no idea, oh my god, the calculus you have to do with trig, the more you're able to do this kind of thing, the more you can simplify a function before you attack it with weird-ass calculus stuff. The thing I've said so many times in my calculus class is, before you try to attack a function with calculus, simplify it. And the more you know about trig identities, the more you can simplify trig functions. Okay, maybe. And then it becomes either easier or possible once you've simplified it. Okay, so let me see if you guys, is everybody semi-cool with this? Semi? So again, what did we do? One side had no fractions, so we said, let's put these fractions together. Then we're getting closer, yes? That required us to realize how to get LCD in this situation, and then we had to be careful about the negative. Okay, so a lot of places to trip up here, I understand that. But as long as you show me as much as you can, I'll give you as many points as I can. Look at C. I'm gonna let you guys think about the first couple steps you might take. Try to do something. Try something. This is a beautiful time to make a mistake because it's not going to count against you. Come back, please. Let me grab my glasses. Yeah, exactly. Yes, yeah. That just tells me you understand what that just said. Because a lot of people do stuff and don't even realize they just are like, I don't know what to do now. What have you done? Yeah. Good. So in case you're stuck, here's the second thing in my list of stuff. One thing we know is if one side has fractions and the other side doesn't, get those damn fractions together. You're always moving in the direction of the other side. Can you guys tell me which trig function up there has a completely different angle than the other ones?
The y and then the x.
Do you see how this cosine has an x angle, yes? Does anybody else have an angle that's x? You guys see what I mean? Isn't this cosine acting on an angle of x? Is that cool? Because that's what's inside of it, and there must be an angle. Anybody else have an angle of x? This guy, yeah. All right, this guy's got an angle of y. Anybody else have an angle of y? Yeah, that guy. What's this guy got? What's angle is he talking about? X plus y, completely different angle, correct? If x is 45 degrees and y is 30 degrees, that dude's working with 75 degrees. Ain't nobody else working with that shit. Does it make... I really want you to get this because this is stuff I was never told when I learned this shit. There's the only way that these two sides could be equal to each other is if I can make all the angles agree. Nobody's got an x plus y angle on this side, do they? So how could this side equal that side until I get this guy broken up? Do I have a way to break up cosine of x plus y?
Yes.
Do it.
How about?
So when you're looking at a problem, huh?
You're there.
You don't have to. When you're looking at a problem, you'll have to be able to do. Take a real quick look. Do all the angles agree? If there's one angle that's an odd man out, focus all your attention on him. Rewrite him, because he doesn't go with everybody else. There's no way to show they're equal if they don't go together. Yes, sir. Yeah, let me see. So the only mistake is, okay, when I have something like 5 plus 15, 5 is being applied to 5.
They will, but it's funny the way I do what we said.
So you have to take this divided by this minus this divided by this. Because do you see how this doesn't really work yet? That's not true. So you're killing things, but you're not really allowed to, because the only way this could cancel is if it's in both ways, and it ain't. So this divided by this minus this divided, and then simplify,
Okay.
and then you'll be there too.
That's fine. I went backwards.
You start on the other side.
I worked with the right side,
All right, I like it.
which got me.
Yeah, I like it. I like it.
Basically did what I did here, right?
Yeah.
And then it ended up with that.
Wait. So you multiply. Oh, you rewrote this. Oh yeah, and then you did that to get that. Yeah, beautiful. Kick-ass. I mean, pretty much, Damon. There's always a way. If it works, there's always a way to make it work, no matter where you start.
I cheated too.
That's good. I gotta remember to look at your hands when you're about to take the test.
Mark equals key.
I don't know about that.
Oh, and then there's a.
What's that? Alright, what do you have?
This high jump.
I'm not cheating.
So, the one that I couldn't
I remember.
So what's cosine of cosine
Oh, wait.
y divided by
I
sine?
forgot.
Yeah.
Matching
That's
tattoo.
definition, no?
That's okay.
No. Wrong way around. That's cotangent. That's cotangent order, which is what you
Not
want.
right now.
Yeah.
That's gonna take a.
So always look at the other side as a
No.
hint.
I
Yeah.
did. We have matching tattoos now.
Oh my god. Dude. That's amazing. It looks exactly the same. Holy shit. Alright, let's put my glasses on. Maybe it'll be-
You need glasses.
Huh? You don't like reading glasses. It really sucks, you know. Because I read a lot of books when I was young, so my eyes didn't have a chance.
Do you go to the eye doctor?
Oh yeah.
They give you this?
No. I go to the eye doctor for completely different. Have I ever told you about this one? January 2019, I lost like 80% of the vision in this eye. Like, have you ever looked through like a shirt? You know what I'm talking about? T-shirt? It's basically that, just a little worse. So like right now, I can tell there's people, I can't tell what expression you have. I can't even tell you have a face.
Wow.
But I think you're fine. Okay. So there's no way you guys could really trust that this is true, but I have to go. Well, it's every 5 months now I go and get an injection. So yeah, it's like a genetic predisposition to this. So I got a 5% chance this one goes.
It wasn't, which one is caused by accident? It was just like.
What's this?
Which one is it?
Oh.
That's fun.
What the hell are you doing? Oh, is this?
Is that one?
What is that supposed to mean? That's not what it is though. Mine is CRVO. It's central retinal vein occlusion. Basically, the artery, the vein clamped down on the artery in the
Wait, I
back.
wanna see.
The blood flowed back and damaged my retina. So it's just, this is as good as it's ever going to be. So I remember, real quick, One of my colleagues had a student who brought their son, this little tiny dude, and he had like one of those Nerf basketball poles. This was like a month after this happened. And I was looking around the corner, and the little dude saw me, and he threw the ball to me like, "Here, you try." And I'm like, I had no depth perception. So I'm like, "Oh," and he looked at me like, "Oh, did no one play catch with you?" What's up? Are you diagnosing me though? Okay.
Wait, can I play with the
Wait, but the way you explain how you see things is the same way I see things without glasses.
Really? It looks like really glasses
Well,
work.
I see colors.
No, mine looks
I can
like
see people's
fog.
faces.
Looks like
Oh, no,
like I
that.
said, looking through a shirt.
Oh, yeah, no.
Anyway, why did I talk about that? All right, how we doing with this is you guys, there's a really crucial thing that happens in this problem that's related to a common mistake. So if I take this, how do I rewrite this? Cos x? Cos y?
Minus sine y.
Good.
Minus sine x, sine y.
Now, it's a really easy mistake, and I'm not picking on anybody. I know a few people do. You can't just kill these automatically, because what is being divided by these? What's being divided by cosine x? Both of these. So you have to break it up.
If you were to try and punch me, I would never know. unless he that's how bad it is.
All right, now you can see what cancels here. Cosines. What cancels over here? Sines. What's cosine y over sine y? Cotangent y. Sine x over cosine x. Yep. Check. Alright. You guys kind of with me? Ain't nothing at all obvious about this. You all agree? There's no way in hell you would just go, "Oh yeah."
I mean a little. If you look at it the way I did, like
Yeah, Damien.
Special and smart.
Damien, just to help Damien like brag about himself, he started on this side, made these both like cosine over sine, sine over cosine, and then got LCD and then worked that way. Which is a beautiful example of there's always going to be, no, let me take this back. There will very often be one side that's got more shit you can immediately work with. And there might, very often there's going to be one side that seems to be nothing to do with. So then you start with the one that has stuff to do. But since this works, and so they do equal each other, there's always a way to go from one side or the other. It's just a matter of which one's easier in the moment. It's like part D, which side has more stuff to do? Hell yeah. Right? Let me see. I kind of want to not do him. I kind of want to do these. Look at number 2a. We did a problem like this last time. In fact, I did almost exactly this problem. It was sine. So, do we have 15 degrees memorized?
no.
Thank God. I was waiting for somebody to go, I did just in case. What is 15 degrees related to? Is 15 degrees twice something good? Hell no. It's twice 7.5 is worse. Is 15 degrees the difference between two angles we have? Yes. So do you start to see how there's concrete situations where these identities can come in handy? So there are multiple ways to rewrite this. What's the simplest way to subtract two angles we know?
45 and 30.
Yeah, those are the two angles that we know everything about. And now I can use that cosine of A minus B formula, right? Go for it. Oh, wait. Sorry? Oh, sorry, Sierra. I thought you said. Oh, man. I'm leaving like no time. Let's see. Yeah, okay. We'll just do a few specific ones. me catch up to you guys. Is that cool? You guys with me? We've broken it down into angles we know everything about. So I've taken a problem that was basically impossible to do by hand, and then made it something I could do, even though it kind of looks a little gross. Poor little guy. Anyone have a suggestion as to how to check this besides wait until I finish it and hope I knew what I was doing?
Yeah. No.
How would you check it? You could check this.
By plugging into your calculator.
Yeah, if you plug cosine of 15, can you do it for me? Anybody got the calculator out? What's cosine of 15 degrees? Make sure you're in degrees. Cosine of 15 degrees.
Yeah, 0.9659.
0.9659? Now, somebody else I don't know. Alasia, this is all on you. No pressure. Can you do square root of 6 divided by 4? So be really careful. You have one? Yeah, you have one of the square roots and the roots.
Square root of
6. Yeah, divided by 4. Plus square root of 2 divided by 4.
I saw Casio at Target. I almost bought it.
You're supposed to help me forget about that.
You do the same thing?
I did.
Sweet.
Smart is king.
Don't say that. I think that's part of his invocation, so let's not do that.
Yeah, he gains followers, he gets stronger. So you're actively committing to, my demise. Thanks for that.
If we don't see Albert tomorrow, we know that.
See, but you might help you since you left them in your home. It might be nice to you.
Now, guys, how do I do this problem? Besides change this into degrees. In fact, if I gave this problem, I said you cannot change it to degrees
Oh.
because I am evil.
But even to like try to solve it.
What radian angles do we know? What radian angles do we know the cosine and sine and all that stuff?
Pi over 4.
Pi over 4.
Pi over 3.
Pi over 3.
6.
5 and 6. Do you see how 3, 4, and 6 are all part of 12?
Yeah, unfortunately.
Yes? So then,
5 pi.
also pi over 2.
Okay, 5 pi over.
So you have to think about, so here's what I do. Can I break 5 up in a way so that we're reduced with 12?
5 pi over 3.
So if I make 5, 2, and 3. Alright, I really want you guys with me.
Yeah, I like
If I break 5 pi up into 2 pi plus 3 pi, will each of those reduce to something? Hell yeah. So that's exactly how you do part B. Is you try to think, how could I break the top up so it reduces into something I know? So in this case it would be 2 pi over 12 plus 3 pi over 12, which is pi over 6 plus pi over 4. And then I could do all the same stuff we just did, yes?
Yeah.
Okay, so, my God, I'm talking too long. Here, let me give you guys this, and I'm gonna ask you to do, I didn't put little images on this one, unfortunately. Yes.
No image.
So guys, can you handle finding 2 other people, 3, 6, 9, 12, 13?
They have been found.
No. Try to break yourselves up a little bit, but it's okay. 2 other people, one group is gonna need 4 people total. Let's see, because we have 2, 4, 6, 8, 10, 12, 13, yeah. Or do you guys need my help? Okay, you need my help. Let's see. Aubrey, can you go back? Yeah, can you guys work together? Danica, Melissa, can you guys 3? So maybe jump 1 row back. Anas, can you work with Kelvin and Alasia? So you guys can just be back there. Fatima, can you work with Mao and Corinne? And then Sierra. Sure, why not? Sierra, I'm gonna throw you. No, do you want to work with? Yeah, you stay. I'm not come over there. You be the group of four, and then you guys work here. See what you can
What's your biggest mistake?
It's up to you. You can get something out of this or not. It's not
It is time.
So this two and this one will divide it. So because we have to divide it like these part with this part, we can write it separately. So then you can fix that.
All right, guys. In the interest of time, I'm just going to do the first two. I'm going to do the first two.
So one of this cosine will cancel out with this. It will be left cosine over sine.
Okay.
I would forget what's up here.
And
Okay.
the same thing with the sine is minus. It would be the same thing again.
This one here, we got a major hint from this problem we did earlier together. Yes? So this is one side has two fractions, the other side has none. So it only makes sense to force these guys together to get it moving in this direction. So what does this first fraction need?
So it would be sine.
Yeah, 1 plus sine x. And the bottom would become 1 minus sine squared x, is that clear?
Yeah.
This one needs a 1 minus sine x, and the bottom would become the same thing, which is the whole idea. We want an LCD. This one's nicer than this problem though, because it was a minus in the middle, here it's a plus in the middle, so I don't have to worry about some stupid negative distributing, because it's a freaking plus. So I get 1 plus 1 is 2, that's ground shaking, Jeff. Sine minus sine is 0. What is 1 minus sine squared? Cosine squared. Now let me write this. Let me write this a little different way, because I had quite a few people that don't quite get this. Is everybody cool if I rewrite this like this? Some of you guys don't need to, and you're fine. Just sit there enjoying that. Is everybody cool with me rewriting this like this? Isn't cosine times cosine cosine squared?
Yeah.
Can't I put the 2 in front like that because it's just multiplying anyway? Who cares? What is 1 over cosine? What's 1 over cosine? And what's secant times secant? Done. Okay. So if you need to, this has come up before, and I've seen a few looks of like, what the hell are you talking about, Jeff? If 1 over cosine is secant, 1 over cosine squared is secant squared. Bam! Yes? But that kind of shows you more in your face why that's true. Part B. I would say you could start with either side to be open. Is that the word? But I would start with this side just because it might be the side most of us started with, I think. What is the major difference between this side and that side, besides there's a fraction here? They're not working with the same thing. And it makes sense to start with this side because I can kind of break up the double angle. The bottom, there's only one way to rewrite sine 2x. And what is that?
2 sine theta cosine theta.
2 sine x cosine x. I got you. The top, there's 2 ways to do cosine. So I was suggesting to people to write this in terms of sine and cosine because everything on this side is going to be in terms of sine and cosine. So if I rewrite this side in terms of sine and cosine, it might give me a hint as to what this should to do. Cotangent is cosine over sine. Tangent is sine over cosine. Now look what happened. And this is part the more you understand what I'm about to say, the more you understand this entire thing. This is supposed to equal this. This fraction has sine and cosine on the bottom. This fraction has only sine. Therefore, a cosine must have canceled. Therefore, there must have been cosine squared up here. This has only a cosine, a sine must have canceled, this must have had sine squared, so the sine could have canceled. Then I know what to rewrite cosine 2x as. Cosine squared x minus sine squared x. That is just one way to do this problem, by the way. Certain intrepid young man, he decided to start with that side, and then he noticed what I'm just talking about from the other direction. So if I rewrite this like this, first off the 2's die, right? 4 little 2's. Then I can break this up. Cosine squared over this stuff minus sine squared over this stuff. By the way, something else I've said to my calc class a lot is when the bottom is one term, that kicks ass. That's the one time you're allowed to break it up into parts and then simplify. If the bottom has more than one term, that sucks. Okay. So what happens here? Yeah, one of my poor cosines cancel. And what happens here? One of my poor sines cancel. So then I get cosine over sine minus sine over cosine, which is what I have right there. Check. Kick ass. All right. I love you guys. You're all like, yes, that's that. Now listen, there's only so exciting you're gonna make this, but this is such a crucial part of anything. You don't know until you get there. But trig comes up every freaking where. So the more you're able to do this kind of thing, the more you can handle it whenever it comes up, in whatever form it comes up. So next time, I want to leave some time if anybody wants questions. I don't think anybody got to this one anyway. Did anybody get here?
We just finished it.
So this is basically related to what we just did, right? But this is going backwards. If I have cosine squared theta minus sine squared theta, what's that equal to?
Cosine 2 theta.
Cosine 2 theta. So cosine squared this minus sine squared this, these are the same. They must be the same in order for me to use the identity.
Yeah.
That equals cosine of
2
twice 5 pi over 8. What's twice 5 pi over 8?
10 pi over.
Even better.
5 pi over 4.
5 pi over 4, and that is an angle you know.
Yes.
What quadrant am I in?
3.
Third quadrant, so cosine is negative, and what's cosine of any pi over 4? Root 2 over 2, so it'll be negative root 2 over 2. Okay, now I'll stop. So next time, this one I put on here just to get us ready. We'll do this one together next time. We'll do any of the other ones you want to next time. The next topic is going to be solving these. But I am going to first do a few more identity stuff with you guys because they do take a little while to get used to. But that's plenty. So if you have any other specific questions or whatever, I'll hang out for a bit. Otherwise, I will see you all tomorrow. Let's all pray Aubrey comes back tomorrow. If not, you understand what has happened.